All right, in this case, this is probably the most complicated example that we've done thus far, if only because we got multiple concepts that we're practicing at once. Okay, we see that we are asked to find, once again, how many grams of cadmium sulfide are going to be formed in this reaction. Now, they did give us the reaction. That's good news. And we see that we have these two reactants, cadmium nitrate and the sodium sulfide. They're going to be used to form this product. Okay, so again, we want to find out how many grams of cadmium sulfide can be formed here. And of course, it's going to depend on how much cadmium nitrate we're using and how much sodium sulfide we're using. Okay, and so the last time we were told you have an excess lead-2 nitrate, right? You have all the lead-2 nitrate that you need. Just focus on that one reactant. This time we can't assume that we have all the cadmium nitrate or all the sodium sulfide that we might need. We have to consider the fact that we might run out of either one of those, if that makes sense. And so what we're going to have to do is we're going to basically work this problem 2 times. Okay? We're going to work out the problem, and we're going to say, okay, from the cadmium nitrate that I have on hand, how much cadmium sulfide can be formed? And then we're going to say, okay, from the sodium sulfide that I have on hand, how much cadmium sulfide can be formed? Okay, this is similar to if I showed up in your house and I asked you how many peanut butter and jelly sandwiches you could make with the stuff that you had on hand. You would need to go to your pantry. You'd need to check on the amount of jelly that you have, the amount of peanut butter that you have, and the amount of bread that you have. And the amount of sandwiches that you're able to output would be relying upon all 3 of those inputs. You can't make peanut butter jelly sandwiches just because you went to Sam's Club and brought a case of jelly. Okay, you need bread, you need the peanut butter. And so we're going to basically work the problem out the first time from the perspective of the cadmium nitrate. And so we see we have 0.045 liters of cadmium nitrate. And that solution is 0.35 molar, meaning 0.035 moles of cadmium nitrate per 1 liter. And the liters and liters cancel. So this should equal 0.01575 moles of cadmium nitrate. Okay, and then we can see that 1 mole of cadmium nitrate forms 1 mole of cadmium sulfide. So I won't go ahead and show that how that lines up again, but basically it's a 1-to-1 ratio. So you can see that we'll get 0.01575 moles of cadmium sulfide. Okay, now I only have 2 sig figs here, but we can worry about all that later. Okay, now I'm going to basically start the problem all over again. And I'm going to work it from the perspective of the sodium sulfide. So I have the 120 mils of 0.1 molar. So 120 mils is 0.120 liters. And it's 0.100 molar. 0.100 moles of sodium sulfide per liter. So liters cancel here and here. And then we can look up at the equation and we can see that 1 mole of sodium sulfide gives us 1 mole of cadmium sulfide. And we could see that we can create 0.0120 moles of cadmium sulfide. And again, I think we have just 2 sig figs here, if I recall. Yes, 2 sig figs in the volume. All right. Well, now we've reached where we can make our decision. We can look and see that I have enough sulfide on hand to create 0.012 moles of cadmium sulfide, and I have enough cadmium on hand to create 0.015 moles of cadmium sulfide. And so what we see here is that this is going to be what we're going to make. Okay, we can make this much, but we can't make this. Okay, we're not going to be able to form that. Why? We're going to run out of cadmium. Okay, this cadmium nitrate is going to be our cadmium source in the reaction, and we've run out of it. Okay, so we're going to make 0.0120 moles of cadmium sulfide. The molar mass of cadmium sulfide is 144.5 grams of cadmium sulfide per 1 mole, and it should work out to be about 1.7 grams of cadmium sulfide to 2 sig figs.